Imagine you could travel to the very edge of the universe. What would you find? A wall? A portal? Or something even stranger? Today, we're going to the place where space, time, and reality itself break down. I'm Stella Atlas, and I've spent years exploring the biggest questions in the cosmos. But nothing is more mysterious than the edge of the universe. Today, I'll show you what scientists think is really out there, why the edge is not what you expect, and how this mystery could change everything we know about reality. Ready? Let's go to the edge. First, let's get one thing straight. When we talk about the edge of the universe, we don't mean a physical wall. The universe doesn't have an edge like a planet or a room. Instead, it has a limit called the observable universe. That's the farthest distance from which light has had time to reach us since the Big Bang, about 46.5 billion light years in every direction. Beyond that, we simply can't see, not because there's nothing there, but because the light hasn't had time to arrive. And here's the twist. The universe itself might be infinite, but our view of it is not. As you approach the edge, things get weird. Galaxies near the edge are moving away from us so fast because of the universe's expansion that their light is stretched into invisibility. This is called cosmological redshift. Eventually, they disappear completely. It's not that they're gone, they're just moving away faster than light can travel. So the edge isn't a wall, it's a horizon, a boundary between what we can see and what we can never reach. And here's the mind bender. Every second, more and more of the universe slips beyond this horizon, lost to us forever. If you're fascinated by these cosmic mysteries, make sure to subscribe right now, because what I'm about to show you next will change how you see the universe forever. Let's go even further. So, what's beyond the observable universe? There are three main ideas. 1. More of the same. The universe could go on forever with more galaxies, stars, and planets, just like what we see here. 2. The universe curves back on itself, like the surface of a sphere. If you travel far enough, you might end up back where you started. 3. The multiverse. Our universe could be just one bubble in a vast cosmic foam, each bubble with its own laws of physics. But here's the mind-blowing part. We may never know, because the edge is moving away from us faster than we can ever catch up. And yet, the possibility that there are infinite other universes out there, that's what keeps scientists searching. The more we learn, the more mysterious the edge becomes. If the universe is infinite, there is no edge, just endless space. But if it's finite, what's outside? Nothing? Something else? Or does the question itself not make sense? This is the ultimate paradox. The edge of the universe is not a place. It's a limit of what we can ever know. Here's where the language gets slippery. Astronomers talk about several horizons, and they're not the same thing. The particle horizon is how far light has reached us since the Big Bang, our observable limit today. The Hubble radius is roughly the distance where recession speed equals the speed of light right now. It's a useful scale, not a hard boundary. The event, cosmic horizon, is the truly haunting one. The limit beyond which light emitted today will never reach us, even if we wait forever, because space expands too fast. You can still see some galaxies that are already beyond the event horizon because the light you're catching left them long ago when they were closer. But any light they emit now is gone to us permanently. So the sky shows a mix of reachable pasts and unreachable futures, a patchwork stitched together by time. Why are scientists so confident there's more universe beyond what we can see? Patterns. The cosmic microwave background is astonishingly uniform, with tiny fluctuations at 1 part in 100,000, exactly what you'd expect if our patch isn't special. The positions of galaxies display a subtle standard ripple called baryon acoustic oscillations, like the universe's fossilized sound waves, consistent across the sky. And measurements of geometry show near-perfect flatness on large scales, a hallmark prediction of inflation, which would have stretched space-time far beyond our horizon. These aren't guesses, they're repeated observations that paint the same picture. Our observable bubble is a small window in a much larger reality. Let's run a thought experiment. You point the most powerful laser imaginable toward a galaxy near the edge and fire a message. We were here. Can it arrive? If that galaxy lies beyond the event horizon, no. The beam makes progress locally, but the space in between expands faster than the beam can close the gap. It will never get there. And if you try to go yourself, you don't outrun expansion either. This isn't about speed. Nothing is moving through space faster than light. Space itself is growing, and that growth outruns any attempt to cross it. That's what a causal boundary means. No signal, no probe, no clever workaround. In the deep future, the sky will betray no clues. Distant galaxies will fade beyond detection, red-shifted into silence. An observer in the Milky Way will see an island of stars surrounded by black and may conclude, wrongly, that the universe is small and static. That's why now is extraordinary. We live early enough to witness the afterglow of the Big Bang, to measure the expansion, to map the cosmic web, to know the story while the evidence is still visible. Cosmology is not just about what exists. It's about what can be known, when it can be known.
And every time we build a bigger telescope, the edge moves further away. The edge of the universe is a horizon, always out of reach, always moving away. But that's what makes the cosmos so exciting. If you want to keep exploring the biggest mysteries in space, click here for my next video about the strangest objects ever found. And don't forget to subscribe, because the universe is just getting started. I'm Stella Atlas. See you among the stars.